are meteorites really? That is the question we are going to be asking ourselves this fine day. What are meteorites? Yes, we all know they are chunks of things that fall from the sky, but they are more than that. For instance, they have been revered throughout the centuries as everything from gods to miracle-curing stones. Meteorites have shaped this Earth and made it more conducive to human life. For instance, it was a meteorite that was the final straw that broke the dinosaurs' back and killed them 65 million years ago. This made it easier for our fuzzy little ancestors to crawl out of their hiding places and reproduce fruitfully. Meteors and meteorites can be very scary things. In 1908, a meteorite with a diameter of between 30 to 60 meters across exploded 3 to 6 miles above Siberia. It has been the one impact event that has happened this past century that has had a lot of witnesses. Trees were sprawled in radial patterns and burned except for at the dead center where the trees were still upright, but their limbs were gone, as were their bark. This damage would later be compared to the bombing of Hiroshima, Japan at the end of World War II. The energy released from this explosion over Siberia was over 2,000 times as much, and it was widespread enough that the damage noted above was seen 40 miles from the epicenter. Another scare came in 1976 when a fireball, known today as the Great Daylight Fireball, streaked across the sky over Utah to Canada in less than 2 minutes. If it had hit Earth directly, the 3 to 14 meter object would have created an explosion half the size of the Hiroshima bombing over Utah. These were 2 near misses, and one caused a massive amount of damage to forests without impacting. But some actually do hit, leaving sometimes very massive craters and destruction in their wake. For example, there's a crater outside of Flagstaff, Arizona that is 3/4 of a mile in diameter from a rock that was 150 feet across, impacting at the speed of 40,000 miles an hour. On the other hand, small meteors can do less catastrophic damage. For instance, one fell through the roof of a doctor's office last year and punctured a hole through the ceiling and went through the floor before breaking apart on the concrete first floor. This meteorite is now in the possession of the Smithsonian after they donated money to the Doctors Without Borders. The Smithsonian wanted it, but they can't buy meteors. They must be donated. So, they wanted it because it was a significant piece of Washington, D.C. and Virginia history. So what would it look like if a soon-to-be meteorite was headed in your direction? Well, here's a police dashboard look at one falling to Earth over Edmonton, Canada. That was an amazing clip. But does that answer the question, what is a meteorite? Well, here are some experts to explain it to us.
The differences among meteors, meteoroid, and meteorites are rather subtle in their nature, as their names might suggest. The basic thread that ties them together is they consist of a small amount of material, rock or metal, that is floating in space. This is a meteoroid. Up here, out in space. They all start out as meteoroids. Then, upon entering the Earth's atmosphere, they begin to vaporize and are classified as meteors. In the middle here. Upon contact with the Earth, or if it hits something like a man-made structure, or perhaps a person's head, or a dog, it is a meteorite. Down at the surface. Meteorites, when found on the surface, look a lot like Earth rocks, but they are burnt because they have just traveled through miles of relatively thick atmosphere when you compare it to the vacuum of space. But where did these meteorites originate from? Well, they come from many places. Some come from a comet's tail when the Earth passes through the debris. Meteors fall into the atmosphere. Others come from meteorites colliding meteoroids colliding with things such as asteroids, or even planets and moons and other meteoroids. Some of them, however, are just general debris floating around from the original nebular structure created the solar system. You can identify meteorites in a variety of ways without knowing their composition. For one thing, a meteorite will have a fusion crust, a thin layer of glassy hard material that is from the superheating of the meteorite as it went through the atmosphere. They can, in theory, be any shape due to the fracturing on impact, but they are most likely to be aerodynamic in shape from when they fell. Another quality is that about 90% of meteorites contain iron in some percentage amount, so that it might attract a magnet.
That was really interesting, Professor Rose. But it still leaves me with the desire to know, what are they made out of?
There are four main types of meteorites that we find on Earth. They are very distinctive from one another in appearance and the origin. Most easily identifiable of them is the iron meteorite. In order to make sure that it is an iron meteorite, it is proper to look for a distinctive shock pattern. This pattern is called a Wittgenstein pattern, seen here. It was discovered by Alois Joseph Wittgenstein in 1808, when he introduced a weak acid to the cross-section of an iron meteorite. The shock impact realigns the nickel-iron crystals into a distinct pattern. Iron meteorites, they are not very common. Another uncommon kind of meteorite is the carbonaceous meteorite. It looks very much like a piece of charcoal, and that is because it is almost 100% carbon. Other than that, there is a small amount of aluminum that is trapped within the carbonaceous formation. Because of this, we can conclude that they came from a supernova, and this also supports the nebular cloud formation of our solar system. The last two types are the stony meteorites. They are the achondrites and the chondrites, seen here. Achondrites come from larger space objects, such as planets, but also large moons like our Luna, dwarf planets like Ceres, and asteroids in general. They are thrown into space by impacts from other space objects. They do not contain chondrules because of the high temperatures needed for differentiation of massive space objects. Chondrites, here again, on the other hand, contain chondrules and have changed less over the past 4.6 billion years than achondrites. They give a unique insight into how the early solar system looked and what it was comprised of. This is because they have not experienced the same types of pressure and heat through the differentiation process as the achondrites. These are the most common meteorites, with 80% found in chondrites.
So what is a meteorite? A meteorite, as we now know thanks to our experts, are pieces of rock, carbon, and iron that are floating in our solar system from impacts and the formation of our solar system. We also know that these objects are called meteoroids, meteors, and meteorites depending on what area they are in. They can be made mostly of iron from the cores of planets, differentiated from being formed in larger bodies and not have chondrules, or have chondrules in them. But the one thing we know for sure is that they teach us a lot about other objects for much less than a trip to their mother object, and while destructive, they can make beautiful lakes, like this one.
Boom! 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 Boom!
Boom!
Sad dinosaur.